Hello everybody. In my previous video, we saw the meaning of advertisements in BLE, what are the different types of advertisements, and we understood the importance of why 2.4 gigahertz is selected as the frequency range for all BLE BT Wi-Fi operations. And for Wi-Fi and BT to perform their operations without any interface, we also understood that BLE will follow frequency hopping spread spectrum. Along with that, we also understood the frequency channels of BLE. So there are 40 frequency channels, and in that 37 are used for exclusively data transfer and 3 are used for advertisements. So today's session will understand what is scanning in BLE, what are the different types of scanning, and few of the parameters like scan window and scan interval, and importance of these parameters and the delay of these parameters, operations of these parameters. So Dimple here again, welcoming you all to today's Android Framework Component session. So without much delay, let's begin with understanding with what is scanning in BLE. So we all saw what is advertisement in BLE, and we understood why 2.4 gigahertz is given as a channel frequency channel for Bluetooth or BLE use. Next we will see what is scanning in BLE. So advertisement means announcement. Obviously scanning is nothing but it's listening in BLE. Here, the BLE device, which could be an observer or a central, that is nothing but which could be a peripheral or a central, keeps listening for potential advertising packets. So here are two parameters which we will come across and which we will learn today. One is scan interval and one more is scan window. So scan interval is nothing but it's the duration between two advertising events. Now I send an advertising events at 1 minute, and after 1 minute I send another advertising event. So the interval or the duration between these two events is 1 minute. So 1 minute will be my interval. This is just an example I gave. So scan interval, it's nothing but it's a duration between two advertising events. Another parameter we need to go through is scan window. Scan window is nothing but for how long a scanner listens for these packets which is sent by the advertiser are defined by scan window parameter. So let me show you all through a diagram. So here are the diagrams which show what is scan interval and scan window. So scan interval, which I already told, it's nothing but the duration between two advertising events. Okay, so here is one advertising event and here is another advertising event. The duration between these two is nothing but scan interval, and for how long these packets are sent. Okay, so how long a scanner listens for these packets, that is defined by the scan window. These two parameters, which is nothing but the scan window and the scan interval parameters, both of them define the amount of time for which the radio is on. So radio is switched on during advertising interval or the scan interval only, and ideally the interval will be between 20 milliseconds to 10.24 seconds. Both of these, scan interval and scan window, have definitely an impact on the power consumption of your device. And the exact interval, exact number, so I already told the scan interval will be somewhere between 20 milliseconds to 10.24 seconds, but that again depends on your applications, how you use. For example, if you are using a door lock in your smart home using BLE, if you are using a door lock and this door lock is advertising at a very slow rate, it will definitely take longer for your device to get to know. Suppose if someone is at your doorstep and your door lock is advertising at very slow rate, maybe at around 1 minute per time, okay, at after every 1 minute it's sending advertisement, then it's very difficult. We can't make someone wait outside for that long time, right? Similarly, if there is a temperature sensor and this temperature sensor will set intervals high value as temperature does not change randomly. So your temperature at of your room maybe. Okay, so your room temperature will definitely not keep changing randomly every now and then, right? So that's why set the interval of these temperature sensors very high. Okay, not every now and then. These temperature sensors should not advertise every 10 seconds or every 20 seconds, because every 10 or 20 seconds your temperature really does not change. So how long this interval should be there, when exactly you should send the advertising packets, really depends on the applications you are trying to develop, really depends on the use case actually. So in the door lock system, it should not advertise at a very small rate, right? It should keep advertising every now and then, whereas in your temperature sensor, in your room temperature case, it should keep advertising at a high value. The interval should be very high. I mean, it should not keep advertising every now and then. After some time it should advertise. So I hope this difference you all got as what is the scan interval related to. So whenever we have devices with large amount of battery or a good amount of battery backup, it's always advised to decrease the scan interval and increase the scan window. So decrease the scan interval and increase the scan window duration rather than putting pressure on advertiser, which basically works on coin-sized batteries. So coin-sized batteries are used by all these BLE radios and these fitness devices, right? So instead of putting pressure on these advertisers, it is better to put a pressure on these scanners, which is basically working on larger battery. So in scanning, there are again two types of scanning. In advertisement, we saw there are two types of advertisement. One of the type of advertisement was without establishing connection, where beacons are an example, and the other types was after establishing connection between two devices, where one will act as a peripheral and one will act as a central. So similarly in scanning, we have passive scanning as well as active scanning. So we'll go through this one by one. First we will see what is this passive scanning. So in passive scanning, the scanner listens to advertiser and never provides any response to advertiser. So just for example, here is a scanner, it's listening to the advertiser. Okay, so this device A is advertising and this scanner is listening to this advertiser, but it never acknowledges, it never responds to that advertiser. So this advertiser is never aware of the fact that its packets are received by the scanner. So advertiser never knows if these packets are received by the scanner or no. This is called as passive scanner. So just this device receives advertisement and it never acknowledges. Let us move on to our next type of scanning, that is active scanning. So in active scanning, the scanner listens to the advertiser and issues something called a scan request, to which advertiser responds with scan response packet. So the advertisement is sent from the advertiser and this device provides scan request. Okay, and this scan request is again received by the advertiser and it provides scan response, which is nothing but an acknowledgement. So advertiser will send twice the amount of payload to the scanner and scanner cannot send any user data. So this was the difference between active scanning and passive scanning. With that, we come to an end of understanding what is scanning in BLE. In my previous two sessions, I have been explaining the concepts of advertisement, scanning, and why exactly 2.4 gigahertz frequency channel is selected for all the BLE BT Wi Fi related operations, and all these concepts. And I've been explaining all these through the pictures or cartoon pictures so that you will understand it more clearly. So I just wanted to come apart from the normal PPT presentation and do something differently. That's why I tried out this approach. I hope this helped you all to understand the concepts more clearly. So in my upcoming session, I'll be explaining on the protocol stack of BLE. So please stay tuned to understand more on the protocol stack of BLE. Until then, everyone, keep watching. I'll meet you all soon in my next session. Take care. Bye bye.